How do you prepare for a disaster you can predict but not picture? For Sarah, it was a morning like any other until the TV flashed.
Breaking news, NASA detects new asteroid, Impactor 25, on a collision course with Earth.
Our mind raced with questions. What happened if it hits? Would the ground split or the ocean rise to swallow her home? The answers existed, but they were buried in data she could never access. Welcome to the NASA Space App Challenge 2025. We are Team EclipseZ, led by Noor Jannat, with Aksadul Rashim Nazar as researcher, Waziha Jannat on web development, Safia Taslim UI UX designer, and lastly Farzana Nasser Neha as video editor. NASA tracks over 39,000 near-Earth objects, simulating impacts that could devastate civilization and erase landmarks. Yet, this life-saving data remains locked away in technical databases, completely inaccessible to the public. This creates a critical gap. While scientists can predict these threats, people like Sarah have no way to understand the danger to their homes or how to prepare. Our mission is to bridge this gap. We present Astronex, a platform that makes NASA's data publicly accessible, transforming abstract prediction into understandable risk. First, explore our live asteroid map, which gives the public the same real-time orbital view of near-Earth objects that scientists use. It is directly connected to NASA's own Eyes on Asteroid peer into our platform. Then, our impact simulator starts with real-threat data from NASA's Century Impact Monitoring System, which uses CNEOS orbital parameters to calculate exactly what would happen on the ground. Pick a real asteroid like Vesta or create your own by setting its size, velocity, impact angle, and composition. Choose an impact location and run the simulation. In second, witness the consequences unfold. The crater size, the blast radius, thermal zones, and seismic activity all calculated using NASA's impact physics and USGS geological data. Most critically, it reveals the population at risk. And if the impact is in the ocean, it automatically visualizes tsunami risk zone. But prediction alone isn't enough. Our defense simulator lets users test real defense strategy. Start with a kinetic impactor like NASA's third mission. Here, you just adjust the impactor's mass and the time before collision. Deploy it and instantly see the result. If the calculations are right, the red danger bar bends into a green, safe orbit. You can then test other strategies like a gravity tractor or nuclear disruption. As a last resort, when deflection isn't possible, the system automatically generates evacuation priorities to save lives. Even simulations can be exported as a detailed PDF for emergency planning. In our statistics feature, the historical impact data forms a crucial knowledge base for understanding planetary threats and improving future defense strategies. To make science accessible, our built-in AI buddy answers complex terms in plain language, guiding anyone, student, policymaker, or citizen. We envision Astronex evolving into more than a tool. It will become a global community and digital hub for planetary defense, where people from every background can learn, collaborate, and actively protect our world together. Achieving this requires collective effort. We need your support to grow, share, and ensure everyone has the tools to understand the skies. Because when danger comes from above, clarity must rise from below. Thank you for being with us.